Exceptions using Java. An exception is an event that interrupts the normal flow of a program. These exceptions pop up if you do things like divide by 0, you can't find a resource for some reason, or if there's a mismatch with the input type. Let's say the program asks for a number and you type in a string of characters. These sorts of events interrupt your program. They're called exceptions. There's a way that we can handle them, and that is by using a few blocks of code. Try, catch, and optionally, finally. So any code that's considered dangerous, where it might interrupt your program, you can surround with a try block. Here's an example. So let's say I'm going to take the number 1 and divide it by 0. Mathematically speaking, you can't divide by 0. That causes an exception. More specifically, an arithmetic exception. I'm actually just going to copy this and save it. This code is dangerous. It's interrupting our program by causing an exception. We can gracefully handle this exception so that it doesn't interrupt the normal flow of our program. Any dangerous code, we're going to surround with a try block. Try and a set of curly braces. There we go. However, if we have a try block, we also need a catch block. We will catch any exceptions, but we're going to list the specific kind of exception we're going to catch. Well, let's catch that one exception, that arithmetic exception. This is the type. We're setting up a parameter here. Arithmetic exception is the type. We will give this exception a name of E for a nickname. If we encounter this exception, we can take a different course of action instead of interrupting the program. So let's do the following. Let's output, you can't divide by 0, idiot. So if we run this again, it shouldn't interrupt our program. We catch this exception and output this text instead. So any code that's dangerous, where it might cause an exception, you can surround with the try block. You can add more than one catch block to catch and handle specific exceptions. So this time we're going to accept some user input. We'll need a scanner. For now, I'm going to write the scanner outside of the try block. Near the end of this video, there's a feature called use with resources. I'll show you how to do that later. Scanner scanner equals new scanner. Type system.in, and then import this class. Import java.util.scanner. Anytime you accept user input, it's almost always dangerous code, because a user can type in anything. This time, let's prompt a user to enter a number. And I will use print. Let's create a local variable of int number equals use our scanner, call the next int method to accept an integer. And then we'll just output our number. Enter a number. How about no? I'm going to type in the word pizza instead. Well, we get an exception. An input mismatch exception. Java was expecting an integer, but we typed in a string instead. We can handle these exceptions too. And I'm just going to copy the name of this exception, because we'll reuse it. Let's catch the following. Let's catch any input mismatch exceptions. This is the type. We will give this exception a nickname of E. So this exception we actually do have to import. Import java.util.input mismatch exception. In case there's a mismatch with the data type, we're asking the user for a number, but they type in a string. Let's output the following. Let's say that wasn't a number. Let's try it again. Enter a number. I'll type in the word, I already did pizza, let's do taco. That wasn't a number. And our program finished with no problems. You can catch and handle more than one exception. There is a catch-all statement that you could add. You could catch all exceptions, exception E. Using this by itself isn't good practice. You want to let a user know exactly what went wrong. If all else fails, and there's an exception that you don't anticipate, you could just say, something went wrong. You could technically use this by itself, enter a number. For example, I'll type in hot dog. Something went wrong. This does prevent our program from being interrupted. It is good practice to let the user know what went wrong exactly. I'm looking at you, Microsoft. Catching all exceptions acts as some sort of safety net. You should only do it at the end, in case there's something you don't anticipate. It is better to catch and handle specific types of exceptions, because you can let the user know what went wrong exactly. Now, there's also the finally block. This is optional. Finally will always execute, whether there's an exception or not. This is where you might clean up any resources. For example, with my scanner, I forgot to close it. We can actually close it within the finally block. When we're done with our scanner, let's close it. Because if we encounter an exception, we might not close the scanner. Other times finally might be useful is if you open a file within a try block, then you'll want to close the file when you're done with it. You can do that within the finally block. For testing purposes, I'm just going to add this always executes. All right, let's do a test run. Enter a number. I'll type in 123, and then we output 123. See, that finally block does execute. This always executes. If we encounter an exception, enter a number. I will type in taco. We get our exception message for input mismatch, and then that finally block does execute. Finally is quite often used for cleanup, cleaning up your program when you're done with it. When you open a file or resource, you want to close it. We'll have more practice with this on the next topic of file handling. Now, there's also try with resources. And actually, Java is recommending this. Rather than declaring our scanner outside of the try block, we can place within a set of parentheses. And then Java is automatically going to close those resources when it's done opening them. So this works too. So enter a number, 123. Enter a number, pizza. That wasn't a number. All right, everybody, so those are exceptions. They're events that interrupt the normal flow of a program. Exceptions occur when you divide by 0, you can't locate a resource, or there's a mismatch of the input type that a user types in. You'll want to surround any dangerous code with a try block. Anytime you accept user input or try and locate an external resource, that's almost always dangerous code. Try any dangerous code, catch any exceptions, and optionally, you can add finally to do any resource cleanup. And well, everybody, those are exceptions in Java. Alright, everybody, in this video I'm going to show you how we can write a file using Java. After doing some research, I've encountered 4 popular options. The first way I'm about to show you is the most simple, and it's what I'll be demonstrating in this topic. We'll be using a file writer object. It's good for writing small or medium-sized text files. There's also buffered writer. This has better performance for large amounts of text. Print writer is best for structured data, like reports or logs. Then there's file output stream, which is best for binary files such as images or audio files, files of that nature. In this topic, I'm going to cover file writer, just so we get the hang of the basics. I might make videos on the other writers, but I haven't decided yet. Here's how we can write a basic file using Java. We'll need a file writer object. File writer, I'll name this file writer, just writer for short, equals new file writer. Then we need to pass in a file path or a file name. Let's create a file named test, and include a file extension. Let's say it's a txt file, a plain text file. Now you could include an absolute file path. I'll show you how to do that later. Our plain text file, a test, is going to appear in our source folder. Reading or writing files is kind of unpredictable. You could consider that dangerous code. Any dangerous code we want to enclose within a try block. Try this dangerous code, catch any exceptions that might interrupt our program. With modern Java, you can try and open up some resource. Add a set of parentheses after try. We will try to open up a file writer object. So, file writer, writer equals new file writer. Then we have our file name, including the extension. Now we do have to import this class. Import java.io.filewriter. If for some reason we can't write this file, we might encounter an exception. We will catch any I/O exceptions, I/O meaning input-output. catch any input-output exceptions. That's the type. We will give this exception a nickname of E. Then we do have to import this class too, in order to work with IO exceptions. java.io.io exception. In case there's a problem writing this file, we'll catch this exception if it comes up. This acts as more of a safety net. If we encounter this exception, we can say something generic such as could not write file. But it is best practice to handle specific kind of exceptions first. Momentarily, we're going to add a catch clause for a file not found exception, in case we can't locate a file path, but we'll take care of that in a moment. Within the try block, in order to write a file using Java, using file writer, we will take our file writer, which we named writer, call the write method, and then pass in a string. Let's say I like, then pick your favorite food. As you know, my favorite food is pizza. Then after writing this file, if we don't encounter any exceptions, we'll print a confirmation message. Let's say the following: file has been written. All right, let's test this. File has been written. Since we didn't specify a file path, your file is likely going to be within your source folder. And here's mine, test.txt. And it says the following: I like pizza. Now, you could pick a different location. For example, you could use an absolute file path. So let's say I would like to write this file to my desktop. So what I could do, I'm going to go to my desktop. I'm going to get the file location of my desktop. I'll just right-click on one of these folders. Go to Properties, copy this location. Then I'm going to paste that file path. You'll likely need to use double forward slashes. Java interprets a single forward slash as an escape sequence, so you may need to use double slashes. When I write this file, it should be at this location, this absolute file path. Let's test it. File has been written. Let's go to my desktop, and here's that file. Test. It says, I like pizza. Let's say that we get the file path wrong. Instead of desktop, I'll misspell this as desto. Run this again. We encounter that exception, could not write file. That's because Java couldn't locate this file path. I misspelt it. Now, when handling exceptions, it is best practice to catch specific types of exceptions first. Here we're relying solely on our safety net that catches all input-output exceptions. Another kind of exception that we can catch is the following: file not found exception. We will give this a nickname of E. Then we do need to import this class, java.io.filenotfoundException. This is if we can't locate a file or a file path is invalid. So let's output the following: could not locate file location. Let's try that again. Remember that my file path is misspelled. Could not locate file location. Let's spell this correctly this time. I'm going to delete this file. Maybe I'll add another line of text. I like pizza. It's really good. Okay, let's try that again. File has been written. Going to my desktop. Here's that file. And it says, I like pizza. It's really good. For better organization, what you could do is create a string of file path and set that equal to a string. We're going to cut everything within our file writer and paste it within the string. We're going to assign the string of text equal to a string variable, a file path. Then we'll pass in the string variable to the file writer. And instead of passing in a string literal to the write method of our file writer, for better organization, let's create a string of, let's say, text content equals, and then we'll cut our text. And then pass in the text content. Let's see, I'll add another line. I like pizza. It's really good. Buy me pizza. Okay, let's run this again. File has been written. Go to our test file. And here's our test file. I like pizza. It's really good. Buy me pizza. If you have a string that takes up multiple lines, another option is to write a multi-line string by using a triple set of double quotes. So this is if you have a lot of text. This time I'm going to write a poem. Roses are red. Violets are blue. Booty, booty, booty. Rockin' everywhere. Alright, so this is a multi-line string. You use a triple set of double quotes. That's if you have a lot of text to write. Okay, let's test it again. File has been written. Let's go to our desktop, open this file, and here's our poem. Roses are red, violets are blue, booty, 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 rockin' everywhere. Alright everybody, so that is how to write a file using Java. To write small or medium-sized text files, you can use a file writer, but you will need a try and catch block. And well everybody, that's how to write a file using Java. Hey everybody, in this video I'm going to show you how we can read a file using Java. After doing some research, there's 3 popular options. The first, and which I'll demonstrate in this video, is to combine a buffered reader and a file reader both together. This technique is best for reading text files line by line. Buffered reader can't read a file by itself. You can say that it acts as a middleman between the program and the file system. It helps us read files more efficiently. And a file reader is what actually reads the file. So we'll be using these two together, which I will demonstrate momentarily. Another technique is to use a file input stream, which is best for binary files, such as images and audio files. Then there's also random access file. That's best for reading or writing specific portions of a large file. So use this if you need to read something specific from a big file. In today's video, we're going to combine a buffered reader and a file reader together. But first, we need a file to work with. Pick a location where you would like to read this file from. For me, I'm going to create a file on my desktop. I will create a new text document. I'll name this test. And what should our file say? Think of something to write. So there's a poem that I like to use. Roses are red. Violets are blue. Booty, booty, booty. Rockin' everywhere. We will need to name this file, including the file extension. I'm going to right-click, go to Properties. This file is a plain text file, a txt file. I'm going to copy this location. I will create a string variable named filePath equals, then within a set of quotes, because we're working with strings, I will paste that file path and include the file name, including the extension, test.txt. Now we're going to be combining a buffered reader and a file reader together. First, we will create a buffered reader object. Buffered reader, we'll name this reader equals new buffered reader. We will need to import this class. Import java.io.bufferedReader. We can't create a buffered reader object without first passing in a reader object, which is why we'll be combining this with a file reader object. Within the constructor, we'll be passing in an object, a new file reader object. And then we do need to import this class too. Import java.io.fileReader. Within the constructor of our file reader, we're going to pass in that file path, that string. When reading and writing files, you'll need try and catch blocks. You can see that Java is already giving us a warning. When working with files, it's considered dangerous code, because you don't know if you'll actually locate that file or not, or reading or writing that file might be unsuccessful for some reason. We will use a try and catch block. Try this dangerous code, catch any exceptions. With modern Java, you can use with resources. We will add a set of parentheses after try, copy the snippet of code where we create a buffered reader object, and then paste it within that set of parentheses. Remove the semicolon. When using try with resources, you'll automatically close this reader when you're done with it. We're going to catch any file not found exceptions within the catch block. So catch file not found exception. That's the type. We will give this exception a nickname of E within the parameter. And we do need to import this class as well. Import java.io.filenotfoundException. If for some reason we can't locate this file at this file location, let's output the following. Could not locate file. To catch all other input-output exceptions, we'll add another catch block. This will act as a safety net. We will catch any IO exceptions. IO exception. We will give it a nickname of E. This is where we'll say something went wrong. And import this class as well. Just temporarily within our try block, I'm going to output that file exists. So let's test it. That file exists. So that file is at this file location on my desktop. For some reason, if we can't locate that file, let's say that I misspelled desktop as desto, run this again, well, we get that exception, that file not found exception, could not locate file. Let's make sure the file path is correct. Now here's how to actually read the file. Within our try block, let's create a local variable of line. We'll be reading our file line by line. Since we're reading this file line by line, we'll be using a while loop. During each cycle of the while loop, we're going to write the following within a set of parentheses. We're going to set our string of line equal to, use our buffered reader object, call the read line method. We're taking our reader, reading the current line. This will return a string, which we're assigning to the string variable of line. After reading one line, our reader is going to point to the next line. However, if we run out of lines, the readLine method is going to return null. So we're going to continue reading lines while line does not equal a value of null. Use the reader, read each line, assign it to this variable of line. If we run out of lines, if this is null, we'll escape the while loop. During each cycle of the while loop, we'll output each line. It's going to be a string. And now this should work. Let's test it. And here's our poem. Roses are red, violets are blue, booty, 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 rockin' everywhere. So that's one way in which you can read a file using Java. You can combine a buffered reader and a file reader. It's best for reading text files line by line, but there's other methods you should be aware of too, such as file input stream and random access file. I'm not sure if I'll make videos on these yet. And well, everybody, that's how to read a file using Java.